If you walk into the National Hurricane Center in Miami during hurricane season, you can really feel the pressure. It's intense.
Oh, yeah. It's not just some office, right? It's basically concrete fortress.
Exactly. Built to withstand a Category 5. And inside, everyone's glued to these screens, looking at satellites, radar, those spaghetti plots.
And the stakes are just incredibly high. You get a forecast wrong, even by a bit.
It could mean evacuations start too late. Every single minute counts.
Totally critical.
So imagine this scene last spring. Ferran Alet and Tom Anderson from Google DeepMind show up. No big fanfare, just a prototype.
Right. Not selling hype, just showing the tech.
You give this demo, and apparently the room just went quiet. Then this veteran forecaster, someone who actually wrote a paper saying track forecasting had stalled, he just leans back and says,
What did she say?
"Potentially revolutionary." That's the quote.
Wow. Coming from him, that's significant.
And you know what got him? It wasn't flashy graphics. It was pure speed.
Uh-huh. The processing time.
Yeah. This AI model, it could run 50 full 15-day storm simulations.
That's 50 simulations. How fast?
In under a minute.
Under a minute. That's game-changing.
And, importantly, early tests showed it beating the ECMWF ENS model, European model, kind of the gold standard on-track error.
By how much?
By about a day and a half.
A day and a half better track. Incredible.
And now, this tool, Google Weather Lab, it's not just for them anymore, it's open.
Right. It's accessible to basically anyone.
You, me, any weather geek out there can go poke it with a stick.
Which brings us to what we're doing today in this deep dive. We really want to unpack how Google Weather Lab works, why it's such a big deal for forecasting, for planning.
And what it means for anyone just curious about, how these massive storms behave.
Exactly. What possibilities does it open up?
Okay, let's start basic. If you had to boil it down, what is Google Weather Lab? One sentence.
Okay. Think of it as a public cockpit. Anyone can jump in and watch Google DeepMind's latest cyclone forecasts right next to the best traditional physics models.
Cockpit. I like that. So you see everything side by side.
Yep. It runs 3 AI systems, Live, GraphCast, GenCast, and this new one, FGN, plus the standard output from the ECMWF ensemble.
And it's interactive.
Totally. You can switch between start times, slide this bar to see how forecasts change over time, turn uncertainty cones on or off, really dig into any specific storm.
So real-time tracking without the usual jargon or needing a subscription?
Precisely. It's democratizing access to this high-level forecast data.
Okay, but let's play devil's advocate. My phone gives me a weather forecast, shows me radar. Why do we need another weather tool? Isn't that enough?
That's a really fair question. It comes down to the difference between, like, a consumer weather app and a professional or research tool.
How so?
Your phone app, it's great for, will it rain at 2 p.m., gives you maybe a 48-hour local forecast, nice icons, maybe a simple probability.
Right. Pretty basic.
And it's kind of black box, right? You don't see how it got that forecast. It's designed for general consumers, for comfort.
Okay. And Google Weather Lab?
It's global, 15 days out. Multiple models side by side. You see the full range of possibilities, the entire ensemble straight, not just one number.
So not just if it might rain, but how many ways it might rain or how a storm might track?
Exactly. You get raw data you can download. The methodology is open. It's built for meteorologists, emergency planners, researchers, people who need deep situational awareness.
Situational awareness versus comfort. That's a good way to put it.
Yeah, you can look at 50 possible futures for some disturbance way out in the Atlantic that hasn't even formed yet. You can measure how the uncertainty grows over time. Compare AI to traditional models directly. It's a whole different level of insight.
It lets you weigh possibilities, not just react to certainties.
That's the core shift. Proactive strategies based on probabilities.
Okay, this AI engine sounds fascinating. Let's get into that family tree you mentioned. Where did this start?
Right, so rewind to November 2023. GraphCast comes out. It kind of stunned everyone because it matched the big physics models on accuracy globally.
But it was way faster.
Hundreds of times faster. It uses this graph neural network structure. Think of it like mapping connections across the globe. It was deterministic, though, one input, one output.
Okay, then what?
Then, January 2025, we get GenCast. This one added randomness, stochastic noise to create an ensemble. Multiple possible futures.
And that was the first AI ensemble to beat the ECMWF.
On overall skill, yeah. It used a technique called diffusion. But, like GraphCast, it still had a bit of trouble nailing cyclone intensity accurately.
Which is obviously pretty important for hurricanes.
Crucial. So that brings us to the new player, the FGN Cyclone model in Google Weather Lab, launched August 2025. It's specifically designed to tackle that intensity problem.
How does it do that?
It combines two key things: standard weather data, like the ERA5 reanalysis for the big picture atmospheric flow, and a custom-built archive of like 5,000 past cyclones, all labeled with details like wind speeds and pressure drops.
So it's trained specifically on storm behavior.
Exactly. And its trick isn't diffusion. It uses this single-step perturbation method. Imagine it's not just adding noise, but slightly tweaking its own internal understanding of the physics 50 different ways.
Like rolling 50 slightly different dice for how the atmosphere works.
That's a great analogy. And then you watch those 50 different storm scenarios play out.
You also mentioned resolution.
Yes. Big difference. FGN steps forward every 6 hours, compared to 12 hours for the earlier models. In the tropics, a lot can happen in 12 hours.
A storm can really spin up.
Right. That shorter step gives these simulated storms more realistic room to intensify, and it gives forecasters better, finer-grained information.
Okay, so simplify FGN for me. No jargon. How does it work? It's magic.
Right. It starts with a good basic forecast, like GraphCast. Then, instead of just tweaking the input weather data, it actually nudges the internal weights of the AI model itself.
So each of the 50 runs is like a slightly different expert opinion on the atmosphere.
You got it. Each member acts like a slightly different theory of how things work, and it's trained using a score called CRPS.
CRPS.
Continuous Rank Probability Score. Fancy name, but basically it rewards forecasts that are not only accurate but also honest about their uncertainty. It penalizes being confidently wrong.
So it learns to give realistic probabilities.
Exactly.
Yeah.
You get sharper, better calibrated spreads. The range of possibilities feels more believable, especially in tricky areas like the Indian Ocean where forecasts can be all over the place.
Okay, back to speed. Why is getting a forecast in 1 minute such a big deal if the official updates only come every 6 hours?
Great question. 3 big reasons. 1, iteration. Forecasters can tweak things, maybe slightly change the starting storm position, rerun it instantly, and see how sensitive the forecast is, right there in a briefing.
Makes sense, too.
Ensemble depth.
Yeah.
Running 50 members takes seconds and costs almost nothing. So for a really dangerous storm, you could run hundreds of members, get a much, much richer picture of the rare but high-impact possibilities.
Things you couldn't afford computationally before.
Exactly. And third, it's just way more energy efficient. A specialized chip running for a minute versus a giant supercomputer churning for half an hour. Big difference in carbon footprint.
Right. And you said the NHC folks immediately saw the value.
Oh, yeah. Their first reaction wasn't skepticism. It was, how soon can we get this into our workflow before the next advisory? That says it all.
And the accuracy improvements are real, right? Let's talk numbers from the recent seasons.
Absolutely real. For track error, compared to the ECMWF ensemble, the FGN model cut about 140 kilometers off the error at day 5.
140 kilometers, that's significant distance.
It basically turns a 5-day forecast into what used to be a 6-day forecast in terms of reliability. That's effectively giving coastal managers an extra 24 hours.
An extra day of lead time, that's huge. What were the actual error numbers?
FGN's average 5-day track error was around 205 kilometers. ECMWF ENS was about 345 kilometers. Big jump.
Okay, and intensity. That was the weak spot before.
Right. And here, FGN's average intensity forecast actually edges out NOAA's Specialized Hurricane Model, HAFS, by about 3 knots averaged out to day 5.
3 knots doesn't sound like much.
It doesn't, but averaged over many storms and forecast times, it's statistically significant, and practically. That difference could be the threshold for telling people to tape their windows or prepare for stronger winds.
What are the intensity error numbers there?
FGN had a mean absolute error of about 13.1 knots. HAFS was around 16.4 knots. So a noticeable improvement.
And remind me of the run times again?
FGN. 55 seconds for the full 50-member, 15-day global run. ECMWF ENS, about 40 minutes. NOAA HAFS, around 55 minutes. Even Google's older AI ensemble GenCast takes 5 minutes.
Wow. Wow. 55 seconds versus almost an hour.
Unprecedented speed difference.
So let's connect this. Maps and numbers are great, but how does this actually change things on the ground? Give me a scenario.
Okay, picture this. Late season, there's this disturbance off Africa, Cape Verde wave, just some clouds, really. You open Google Weather Lab.
Yeah.
It flags it with these little teal circles, maybe a 2% chance of forming into a cyclone, according to the model. You click on one, instantly you see 50 lines. The spaghetti trap shoot forward 15 days, and the ensemble is split. Maybe 20 lines fizzle out over the Atlantic, but 30 lines? They spin up a hurricane heading towards the Caribbean.
Okay, so you see that possibility really early.
Exactly. Now, think about who sees that. An airline dispatcher. They might shift a plane out of San Juan a day earlier than they otherwise would have, just in case.
Hedging their bets.
A relief agency. They might pre-position water supplies in Barbados instead of, say, Guadeloupe, based on where that cluster of storm tracks is pointing.
Decisions based on potential futures, not waiting for certainty.
That's the key. Anchored in contingent scenarios, running cheap possibilities early and often. That's what this probabilistic AI enables.
That extra 24 hours you mentioned.
Yeah.
For emergency managers trying to evacuate a coast, what does that actually look like? What decisions does that enable?
It's massive. 4 days out, deciding whether to issue an evacuation order is agonizing. Huge disruption. Huge cost if you're wrong.
Right.
So if Google Weather Lab shows the FGN ensemble clustering, say 150 kilometers west of where the ECMWF is centered, but the FGN cone is tight right over maybe Galveston, the manager can look at both, see the different possibilities weighted, factor in road capacity, and make a much more informed, potentially earlier call on triggering warnings or phased evacuations. That extra day could prevent gridlock, ensure resources are in place.
Yeah.
It buys crucial operational time.
And beyond emergency management, other real-world uses.
Think airlines again. Dispatchers can pull data directly from the Weather Lab API.
So automatically feed it into their systems.
Exactly. Feed ensemble wind shear probabilities, say a 30% chance of 40-knot headwinds over Bermuda from a subset of the runs right into their flight planning software. They can reroute or adjust fuel loads proactively.
Okay. What about energy?
Renewable energy traders, they care about combined risks. Is it going to be super windy offshore, boosting turbine output, but also potentially rainy enough on the coast to disrupt the grid or lower demand?
The joint probability.
Right. FGN's ensemble gives a view of those combined scenarios, letting them price that complex risk much better than just looking at wind and rain forecasts separately.
It feels like this isn't just about hurricanes, is it? This kind of AI forecasting could apply elsewhere.
Oh, absolutely. The potential is much broader. Think agriculture.
How so?
A farmer or a co-op could use joint forecasts of rain, heat, and humidity over the next 2 weeks to decide when to apply fertilizer or schedule irrigation, hedging against potentially damaging wet or dry spells predicted by the ensemble.
Okay, finance.
Commodity traders, insurance. They could price the risk of, say, a hurricane causing power outages in a specific region by feeding the FGN probability maps into their financial models.
Yeah.
Better ensemble data means tighter risk assessment, maybe fairer insurance premiums. Definitely. Cities could use joint forecasts of heat and humidity to predict high-risk days for heat stroke further in advance, allowing them to prepare cooling centers or issue warnings more effectively.
And even climate research.
Yeah, this is cool. Scientists can take a historical storm, run it through today's AI models, but tweak the conditions like warmer sea surface temperatures and see how the track or intensity might have changed, testing climate change impacts in a controlled way.
So this all sounds incredibly powerful, but let's be clear. Is Google Weather Lab replacing the National Hurricane Center? Is this the new official forecast?
Absolutely not. That's a crucial point. Google Weather Lab is not an official warning platform. The final word, the official warnings, still come from the NHC, the Joint Typhoon Warning Center, the National Met Services.
So what is it then?
Think of it as a research tool, a kind of preview or an extra lens for the forecasters. It's like having a second opinion, but one that runs incredibly fast and explores possibilities differently.
And they work together, Google and the NHC.
Yeah, there's actually weekly collaboration. The DeepMind team shares results, gets feedback, things you see in the interface, like the way the ensemble tracks collapse into that familiar cone of uncertainty, or how tracks are colored by wind speed. Those came directly from requests from NHC forecasters.
So it's augmenting their workflow, not replacing it.
Exactly. It's a complementary tool.
How does it actually show the uncertainty? You mentioned cones and colors.
Right. It gives you 3 layers. First, you can see all 50 individual spaghetti tracks the raw paths.
Okay.
Second, you can toggle on the cone, which statistically represents about 2/3 of the likely track error based on the spread of those members.
A familiar cone.
And third, the tracks themselves are colored, usually showing the intensity probability along the path. So you see not just where it might go, but how strong it might be along each potential track.
And because of how FGN works, perturbing the model itself.
The 50 members look more distinct. They represent genuinely different atmospheric evolutions, not just slight variations on a theme. The spread expands and contracts more realistically based on the weather patterns.
Can you give an example of where this really made a difference?
Yes, Cyclone Alfred, March 2025, over the Coral Sea near Australia.
Okay.
Early on, the FGN ensemble showed this clear split. About half the members weakened it out at sea. The other half curved it towards Brisbane. The overall cone covered both possibilities really well.
And other models?
The ECMWF ensemble at that stage leaned much more towards the out-to-sea solution. It didn't capture that Brisbane threat as strongly.
And what happened?
6 days later, Alfred tracked exactly along the edge of that initial FGN cone, grazing the Queensland coast near where that subset of members had predicted.
Wow. So that early probabilistic flag was crucial.
Absolutely. Ports saw that possibility flagged early. They could pre-stage tugboats, tell oil tankers to move further offshore, well before it became the main forecast scenario. It bought them critical decision time based on a credible, low-probability outcome.
Incredible foresight. Okay, looking ahead, what's next? Where does this tech go from here?
Well, one big area is spatial downscaling. Taking this global ensemble and nesting it inside another AI model that runs at super high resolution, maybe like 2 kilometers, and constantly blending it with live radar data.
What would that give you?
Hyperlocal cones of uncertainty. Imagine telling a mayor not just that the city is threatened, but that this specific suburb is likely to see the worst storm surge based on the fine-scale wind patterns.
It's incredibly specific.
Game-changing for pinpoint warnings.
Yeah.
Then there's compound hazard modeling.
Meaning?
Modeling multiple things at once. Not just wind and rain from a hurricane, but maybe wildfire smoke getting pulled into the storm from a nearby drought area.
Wow, okay. Hurricane plus smoke forecast.
Yeah. Think about the public health implications of that kind of joint forecast. It would totally transform planning for complex emergencies.
And all this data. Is it safe to share? Legally, I mean, given it's not official.
Yeah. Google has been very deliberate about transparency here. The underlying ECMWF data it uses is shared under a Creative Commons license. Google's own AI outputs the model weights. The data are available under open terms.
So people can actually download it, use it, build on it?
With attribution, yes. They want people to explore it, understand it, trust it. Making it open invites that kind of scientific curiosity and scrutiny.
It really feels like a shift. For years, hurricane forecasting was this slow, incremental progress, shaving little bits off the error cones.
An exercise in humility, definitely.
And now machine learning hasn't just joined the game. It feels like it's changing the rules, not by ignoring physics, but by adding this layer of speed and probabilistic depth.
It's augmenting it, exactly. Google Weather Lab really puts that leap on display. It feels like the beginning of an era of giant intelligence, human expertise working with AI insight.
So, for everyone listening, go to the site. Play with that slider that moves time forward. Watch those 50 possible worlds light up across the map. Each line tells a story: wind, water, chance.
Yeah. Folks at the National Hurricane Center are still the ones keeping watch, making the calls.
But now they have this incredibly deep, incredibly fast ensemble tool to help them look further and clearer. And now, so do you.
That's the amazing part. Access.
So if you found this deep dive interesting, share it. Send it to that friend who loves weather, or maybe someone who lives on the coast, or, anyone who still puts tape on their windows when a storm is brewing.
Definitely keep Google Weather Lab bookmarked.
Because the next hurricane season, it's already spinning up right there in the data.